So our first slide deck is about methods and using methods. We're going to talk a little bit more about the name methods and why we're going to start calling something that we previously called functions a method. So we're going to learn a little bit more about terminology. So up until now, when we've been talking to you, we've been saying use the function, the inbuilt function fill, or use the inbuilt function size, use the inbuilt function rect, or whatever it is. So from now on, we're going to start using the word method, because in Java, we always use the word method. In processing, it's a function that we're calling. So we may sometimes still say, that's a function, but we really are now should be using the word method. So it's just terminology at this moment in time. So if you're listening to YouTube videos or reading and you come across the word function or the word method, we're telling you now it's the same thing. So because this code is primarily around using the Java language, we're going to start using the Java terminology, and that is method. Okay. So what are methods? So a method is a reusable block of code that performs a specific task. So what it means is we're going to create a piece of code that's going to do something that we want to do, and then we're going to call upon it every time that we need that piece of code to be done. So I always think of a method, something similar to the chorus in a song. So if you see a song, you'll have the words for the first verse, then you'll have the word chorus, the words for the second verse, then the word chorus. And when you're singing the song, you'll sing the words for the first verse, and then when you see chorus, you'll go to where chorus is written. You'll sing the song, the words for the chorus, and you'll return back and you'll continue on with verse 2. You'll sing verse 2, you'll see the word chorus, and you'll go to where the chorus is. So that's the kind of same idea as what a method is. We're going to write the code once that we want to be executed, but we can call upon it many times. So it helps organize the program by breaking it into smaller, more manageable parts. Methods can be called whenever needed, reducing repetition and making the code easier to read and maintain. And methods help us so we don't have to write the same instructions over and over again, and they make our code cleaner, faster, and more fun. I don't know where the more fun came out of, but let's pretend that that's true, because for some of us, programming is never fun. Although, to be fair now, processing is, because we can do lots of fun things in processing. So what are our topics list? So we're going to look at the method terminology. So what does the word return type mean? What does method names, what are method names, and what is the parameter list? So up until now, you've been using return type. When we say void setup, void is our return type, and we've told you that means it returns nothing. So we're going to explain what exactly that means now. So methods in processing. Processing comes with several pre-written methods that we can use. I nearly said functions. Pre-written methods that we can use. It's a set of instructions that perform a task for us. And when we invoke or call the method, it performs the task. So up until now, we have said that some nice person somewhere, or some team of nice people, have written these pieces of code for us. So we don't have to. So somebody wrote background, somebody wrote size, and we just call it in our program. So we call size and we pass it the parameter, we pass it the information it needs to perform its task. So these are methods that are written for us and we call. So we call stroke, we call no stroke, we call stroke weight. Okay. So these are the methods, some of the methods that we have been using so far. So these are pre-written methods and they're system methods. We have also written two methods to animate our drawings. So in these methods, we have called them. In setup and draw, we have written the code for the setup, and when we have written the code for draw. So setup and draw are two system methods that processing knows about and processing calls. So remember, processing calls setup automatically when the program starts. And in that, we typically wrote the code to set up the screen size, the background color, etc. Processing calls draw 60 times a second. So it automatically calls straight after the setup, and then it continuously executes the code inside it at 60 frames per second. And we learned about that. So let's have a look at the methods that we've used. We've used setup. So the terminology there is the method signature is the heading. So void means it's its return type. Setup is its name, and then we have our brackets. What's inside our curly brackets is the code that we want to be executed, and that's called our method body. So our method body in this case here is the code that's going to be executed when setup is called. Okay. So this is our signature. It has a return type. So the return type is whatever is being returned from this method when the method has executed the code. So in this case, we're saying it's void. So setup doesn't return anything. Setup knows what it has to do, and everything it has to do is between the curly brackets. The method name is setup. So this is the name that we're given to the method. And inside the brackets, we have a parameter list. Our method signature will always follow the same structure. It'll always have a return type. It'll always have a name. It'll always have brackets, the round brackets. Inside of those round brackets, it may or may not have a list of parameters. And what we mean by a list of parameters, we mean that we might need to pass information to our method for it to do the job that we want it to do. So if we go back to our chorus example, there might be a key change on the chorus. So when we say chorus, we might pass it a new key to sing the song in. Okay, and that's what our parameter list is. It's the information that's going to be required by this method to do the job that it needs to do. Okay. So methods can return information. The void keyword just before the method name means that nothing has been returned from this method. So void is a return type, and it must be included in the method signature if your method returns no information. Okay, so if our method executes its code and has all the information it needs to do its job and doesn't need to return it anywhere else, then it's void. We're not returning anything. When a data type appears before the method name, it means that something is going to be returned from this method. So within the body of the statement, we're going to have the keyword return. So it's going to return a value. So when we say int something and then our brackets, it means that when our method has completed its job, it's going to return a value. And we're going to see some examples later on when we get to our times two tables. So we'll see that we return something. And when we say return, we mean we return it to wherever has called this. So wherever is calling this method has to expect a value to be returned. And then the data type that we return can be an int, a float, it can be any of our primitive data types, and or it could be something else that we haven't looked at yet called a class. Okay. So here is an example. So in our code, we have int val equals 30. So what is that again? That's a global variable. And we said that when we create a variable globally outside of a method, it means that all of the methods in this code base can see it. So we're saying int val equals 30. In our draw, we're going to call our times2 method, and then we're going to print the result. So our times2 method this is it here. It has a return type of an int. So when it has a return type of an int, we have to have a variable created here to store that value in it. So what are we doing? We're taking whatever is returned here and we're placing it into our space and memory called result. So here is our method. So it's int times2. We're passing it in a number, and the number, what we're doing is we're going to multiply that number by 2, and then we're going to return it. Okay, I'm actually going to write that code into processing just to give you an idea of what we're doing. Okay. So we're creating a variable. Made that 40, that should be 30, sorry. We're saying void draw. So you can see one thing that I always do when I create anything, a block of code, and I have an opening curly brace, the first thing I always do is I type in my closing curly brace, and then I go back and I start typing. Okay, I'm going to come back to this one in a second. And first of all, I'm going to write my method. So I'm going to go int times2. So the name of our method is times2. It's returning an int and it's expecting a piece of information. It's going to expect me to pass it a number. Oops. Open curly bracket and close curly bracket. Oh, and sorry, it was number. So I'm going to pass it in something. Now you can see here that it has a squiggly line and it's telling me I need to return something. So because I'm telling it to expect a return, when I write my code here, I have to make sure to have a return. So I'm just going to say number is equal to number multiplied by 2. And I'm going to say return number. So what's happening there? I'm going to pass it in a value. It's going to take that value, it's going to multiply it by 2, and it's going to place it back into my variable, and then it's going to return that. So up here, I want to do something. I want to call this times2 method. To call it, remember, it returns something, so I need to store what it returns. So I'm going to say result. Again, these are just names. You can call them whatever you want. And I'm going to say times2. It's passing it the val. So it's passing it whatever stored in val. And then I'm going to print it out. So when I play that, you can see down here, it's taking, oh, look what I've done wrong. I was printing val, not number. Sorry. Not result. Oh my gosh. So you can see here, it's printing 60. So why is it printing 60? Because draw has been called 60 times a second. So 60 times a second, it's calling this method and it's returning it. Okay. If I wanted to, I could say something like this. So now every time it comes in here, it's going to add 1 to val. It's going to pass it to times 2 and it's going to print the result. So now you can see that we have different numbers each time, because 60 times a second, it's adding 1 to val, and then it's calling times 2. It's passing it the new value for val, and then it's printing out the result. And remember, because this is a global variable, it means it's keeping the new value between iterations. Okay, so you can try that yourselves in a sec. So the red int in the method declaration specifies the type of data to be returned. Okay, so this is our method call, and we're saying when we call this method, put the return into result. Okay, so this is our call and this is our definition. In our definition, where we define the method, we have a header. So that's our method header. Okay, and we've said here val is passed in. So there's lots of different variables there. And again, I'm just going to go back to my processing just for a second. I'm going to make that a little bit bigger so that you can see it. Okay, so that looks a little bit better. Our slide is very, it's after getting a little bit too messy. So let's have a look at this again and we'll go through exactly what it's telling us here. So it's telling us this here, that this is our method header. It's telling us that everything here is our method definition. And it's telling us here that this is where we call our method. So this is our method call. We're passing it the number that's stored in val. So what gets passed here is an integer. It's the number. And what we're saying here is, when it's passed to times 2, it's not called val anymore. It's now called number. We're just taking the number, we're multiplying it by 2, and we're updating this variable that we have in here called number, and then we're returning it. Okay, so there's a lot to take in there as to what's happening. So let's have a look again. We're calling our method, we're passing it an integer. When we pass it in here, inside here it's now called number, so we're just giving it a different name, so it's in a different space of memory. We're multiplying that by 2 and then we're returning the new value. That's been stored in result. Result is being printed out, and then we get here and it comes back in again and again and again, 60 times a second. Okay, methods can return any type of data: boolean, byte, char, float, int, string, etc. But you can only have one return type per method. So what method names are we going to use? So method names should be exactly what's happening. So it should be a description of what the method does. So we use verbs like actions to describe it. So if we were creating a method that was going to call calculate tax, we'd call it calculate tax. If our method was going to print results, we'd call it print results. So we're naming our methods, in regards to what they're doing, okay? Because we want it all to make sense. The more sense we make of what we call things, the easier it is for us to remember what it does, and the easier it is for someone who's going to look at our code at a later date to know what it does. So we're descriptive in our method names. So calculate tax, print results. We use mixed case. So the first letter is lowercase and the first letter of each internal word is camel case. And you've heard this before, we call it camel case. Okay, so every word inside of it is, first letter is uppercase. And that allows us to be descriptive in our method names. There's no spaces. If we put a space in, we'll get a syntax error. Okay. So methods take in data via their parameters. And methods do not have to pass parameters, e.g. setup has no parameters. So what that means is setup doesn't need any external advice to do its job or any external information. It just does it. So when we pass a parameter to a method, it means that we're giving it extra information that it needs to do its job. So methods that we've seen already that have no parameters. So no stroke, setup, no cursor. We don't pass them anything. These methods have no parameters. Okay, so they don't need any additional information to do its task. Likewise, if we had a method called output hello, it just prints hello, and therefore it doesn't need us to tell it. If we wanted to pass it in a string or something to tell it what we wanted to print, well, that would be different. But if there's no parameters, there's nothing in those brackets, then the method doesn't need any additional information to do its job. So we've been using methods before up to now that take parameters. So stroke weight, it needs us to tell it how thick we want the line to be. Size needs us to give it two parameters, a parameter for the width in pixels and a parameter for the height in pixels. Okay, so a parameter is a variable declaration. It has a type and it has a name. So in our size, the type is int and the name is width. If a method needs additional information to execute, we provide the parameter so that information can be passed to it. The first method above, stroke weight, has one parameter, so it expects us to pass it a float for it. That's what it needs for it to work. And size has two parameters. So when we want to set the size of our canvas, it requires two parameters in ints and width in pixels. In theory, methods can have any number of parameters. So when we have a method, we give it a name and we pass it whatever information it needs, and it can have any number of parameters. We will also, but not today, see methods of the same name, and they will have different numbers of parameters, and that's what will be used to differentiate them. Okay, so before actually we have any questions, I'm just going to go back to our processing for a second. And I'm just going to quickly go through some of those things that we had on the last slide, on the last few slides. So we're going to say void setup. So again, we're saying setup returns nothing. It's called setup. We must call it setup because processing knows about it. We're calling an inbuilt system function called size. It needs us to give it two pieces of information, the width and the height. We're going to call background. Background. This here is a function or a method, and we can either pass it one piece of information and we'll get a grey colour background, or we can pass it three pieces of information and we can get a coloured background. So we're going to pass it three pieces of information and we get our colour background. Okay. Inside our draw, we might draw a shape. So we said, I don't know, stroke weight. So stroke weight inbuilt method expects one parameter. So let's pass it a parameter. Fill. Again, we said it's an inbuilt method. It expects one piece of information, or we can pass it three. So we'll pass it three. Oops. And then we'll draw a rectangle. Rect, again, inbuilt function. So it expects four pieces of information, a value for the X, a value for the Y. So I'm just saying whatever the width is, divide that by 4. Whatever the height is, divide it by 4. And then it's going to be 200 by 200. So when we run it, we're creating something like this. Okay. If we want to write our own method, we could create our own method that returns nothing. So our say hello. So remember what this is. This is our method definition. This is our header. Our header always has a return type, a name, and a parameter list. And we're going to write our text. And we're going to write our text at maybe 50, and the text that we're going to say is hello. Okay. Hold on for a second. Actually, I'll just print it up, make it easier for ourselves. I'll just print it to the console because I want to change it in a second. Okay, so let's see what happens if I run it now. It draws my rectangle or my square because I have it as the same. Its background is red, but there's nothing appearing down here. So why is it not appearing down there? It's not appearing down here because we never called it. So even though we write our methods, until we call them, it does nothing. And if you think of it, all the methods that are built in to processing that we can call, they do nothing unless we call them. So until we call say hello, nothing is going to happen. So now when I call say hello, we can see it's printing 60 times a second. Okay. So I'm going to leave it at that. Take a break, have a try of some of the things that we've done, and we'll come back then for the next slide deck.